name is Mrs. Williams and welcome back to my flipped classroom. Today's lesson is going to focus on transformation of functions. So far in Unit 3, we have talked about the characteristics of functions, linear functions that have a positive, negative, undefined, or zero slope, as well as exponential functions, which are curves that grow or decay at a very fast rate. Well, what if we wanted to transform these functions? Transform means to change. So, what if we wanted to change these functions? What are the ways we can change them? And more importantly, how can we represent this transformation mathematically? In other words, how do we write these changes using just numbers? Well, that is what we're going to focus on in today's lesson. Make sure that you have your composition book and a pencil so that you can take adequate notes throughout this lesson. Also, be sure to watch the entire video. I will come back at the end to summarize everything that we have learned, as well as assign a short task so you can check your understanding. Without further ado, let's get started. Hi everyone. Like I said before, the title of today's notes is Transformations of Functions. Make sure you write this at the top of your paper. The standard for today is MGSE9-12.F.BF.3. I can determine the effect on the graph of a function by adding, subtracting, multiplying, and dividing specific values to the original function. The essential questions are, number 1, what are the different transformations that can change the graph of a function? Number 2, how do you represent the transformation of a function mathematically? By the end of this lesson, you should be able to answer both of these questions. Transform means to change. You can think about the Transformers movie if you need help memorizing the definition of the word. There are 3 ways that we can change the graph of a function. We can change the location, the shape, or the direction of a function. Let's talk about these 3 things a little bit more. Let's look at transforming the location. By transforming the location, we simply are just going to move the graph on the coordinate plane. Look at the first picture. We have our original function, which is just the blue curve. Now look at the second picture. We have our original function, but the red function shows the exact same curve, simply just moved down 6 spaces. The green curve shows the exact same function, just moved up 3 spaces. Notice we didn't change the shape of the graph, we simply changed where it was located on the coordinate plane. We call these vertical shifts. Remember, vertical means up or down. So, vertical shifts moves a graph up or down on the coordinate plane. Now look at the last picture. Again, we have our original curve, which is the blue function. The red function shows the exact same shape, just moved over 3 spaces to the right. And the green function is also the exact same shape, but moved over to the left 3 spaces. Notice the shape didn't change. We simply moved where the function was located on the coordinate plane. We call these horizontal shifts. Remember, horizontal means left or right. So, horizontal shifts moves a graph left or right on the coordinate plane. Now we're going to talk about transforming the shape. Again, we have our original function, which is the blue curve. But what if we wanted to change what the function actually looks like? In the second picture, we started out with our blue curve, which looks kind of like a V. And we squeezed it together to make the red curve. Now, they look very similar, but we would say that the red is just a skinnier V. We call these compressions. Compressions shrink or squeezes the graph to make them smaller or skinnier. Now look at the third picture. We call this a stretch. We started with our original blue curve, but the green curve shows that V shape, but only a little wider. So we stretched it or pulled it apart. Stretching a graph pulls the graph to make them wider or fatter. Now we're going to talk about transforming the direction. Here we have our picture of the original function, which is that same blue V-shaped curve. In the second picture, we have our blue function. It is pointing down with the vertex on the origin. The red function shows the exact same shape, simply flipped across the x-axis. Notice how its vertex is also on the origin. So the only thing we really changed was the direction. The blue function points down, while the red function points up. Now look at the last picture. We've taken that same blue curve and put it on its side. The blue function points to the right. If we flip it over the y-axis, we get the green function. The green function has the exact same shape and its vertex is still on the origin. It's just simply pointing in the other direction. The blue function points to the right, while the green function points to the left. We call these reflections. You can try to think of it as a mirror. When you look in the mirror, your overall appearance did not change. However, all the directions are now opposite. So, reflections are changes of the direction of the graph by flipping it over a line. Usually, this line will be the x-axis or the y-axis. So, let's recap. There are three ways to change the graph of a function. We can change the location through vertical shifts and horizontal shifts. We can change the shape through vertical compressions, horizontal compressions, vertical stretches, and horizontal stretches. And lastly, we can change the direction by reflecting over the x-axis or reflecting over the y-axis. This is what your notes should look like thus far. I have my title at the top of the page, the standard, and the essential questions. Below, I've taken a few notes from the lesson. You may have more than I have, but that's okay. At the very least, you should have the three ways to change the graphs of a function and each of the individual names of the transformations. Next, you will need the chart that I passed out in class. Notice how I have glued mine on the next page of notes in my composition notebook. You'll need this for the remainder of the lesson. So, how do we represent these transformations mathematically? Well, when we want to change a number, we can simply add, subtract, multiply, or divide. Well, we use these exact same operations to represent transformations of functions. Each of these operations represents a transformation. Add represents a shift. Subtract also represents a shift. Multiply means a stretch, and division means a compression or shrink. Now, depending on where this operation is located, either inside the parentheses or exponent or outside the parentheses or exponent, will determine whether this is a horizontal transformation or a vertical one. Let's look at the example below to further explain. Here we have our original function, which is x squared. Now, if I did x squared minus 3, I can look on my chart to see that subtraction means a shift right or a shift down. But since the subtraction occurs outside of parentheses or the exponent, I know that it is a vertical shift, and it's more specifically a shift downward by 3 units or 3 spaces. In the last example, we have x minus 3 in parentheses squared. Again, I see that my operation is still subtraction, so I know it's some kind of shift. But this time, the subtraction occurs inside the parentheses. So if I go to my chart and I look at subtract, and inside the parentheses, I know that it's a horizontal shift. Specifically, it is a shift right by 3 spaces. Now, let's go on to look at some more examples. This chart is going to be the most beneficial to figure out the transformations of functions. Let's look at number 1, x squared plus 4. The first thing you do is identify the operation. I see that we're adding, so I go to my chart and look up add. I also notice that that addition sign is not in parentheses and is not in an exponent. Therefore, I know it has to be a vertical shift up by 4 spaces. Number 2 is 3 to the x minus 1 power. I see that my operation this time is subtraction. So I go to my chart and see that subtract is either a shift right or a shift down. But this time, the subtraction occurs in the exponent. So I know that I look under the horizontal column and know that it's a shift right by 1 space. Number 3, I'm dividing by 5. Remember that the fraction line means division. Again, I don't have any parentheses, nor do I have an exponent. So I know that this is a vertical transformation. In fact, it is a vertical compression by 5. Look at number 4. Even if I don't know the equation for the function, I can still figure out the transformation. I have a negative f of x. Well, that negative sign stands for an imaginary -1. If I use my chart, I know that multiplying by -1 is a type of reflection. And since the -1 is outside of the parentheses, I know that it is a reflection over the x-axis. Now look at number 5. This one, we have 2 transformations. I multiplied by 2 and I added 1. Well, the multiplication occurs outside of the parentheses and the addition occurs outside of the parentheses. Multiplication means a stretch. So I know that this is a vertical stretch by 2 and a vertical shift up by 1. You should have also written those examples in your notebook, like I have shown you here. They're a great tool to reference when you're studying for any test or quiz. So let's recap. There are 3 ways that we can transform a function. We can change the location, the shape, or the direction. Vertical and horizontal shifts change the location. Vertical compressions, horizontal compressions, vertical stretches, and horizontal stretches changes the shape, and reflections change the direction. Be sure that you memorize the chart that I gave you because it'll be very helpful in the future on tests and quizzes. The most important thing that you need to remember about transformation of functions is horizontal changes are inside the parentheses or exponent and vertical changes are outside the parentheses or exponent. If you remember this rule, then you should be just fine. I hope you found this video helpful and informative. Make sure you come to class with any questions or concerns you may have, and I'll see you next time. Bye!